So try to
Right.
just add 4, 5, 6 references to year 2020 or 21, because at the time the paper will be published, it will be somewhere around 2022, if I'm not wrong. So try to have some
Okay.
references of the latest years, 20. And please
Okay. Thank you very much.
do contact me. Take my email address from the organizer. I would love to collaborate research with you in the near future.
Sure. Sure. Thank you. Nice to meet you
Okay.
here.
Same here. Same.
That was very good. Thank you so much for the presenter. Thank you so much, Mr. Chair. Right, before I call on the next presenter, I would just like to remind again the presenters moving forward. Please be mindful of the time, all right? And I will be reminding you if you have 1 minute left, all right? So let's go ahead and welcome the next presenter, Mr. Kenji Merenciano, to present the paper about Mini Industrial Robotic Arm, MIRA, Learning Package. I can now see your screen. Sir, I cannot hear you.
Ma'am, can you hear me now?
Yes, I can hear you now. Go, I lost your screen. Can you share it again?
Loud and clear po. Yes po, loud and clear.
Yes, loud and clear.
Okay, thank you.
Right, perfect. Proceed.
Good day everyone. To the conference chair, keynote speakers, organizers and staff of the Institute for Engineering, Research and Publication, and all the people behind the success of this 36th World Conference on Applied Science and Technology. Thank you for giving me the opportunity to be part of this significant event. My research is entitled MIRA, MIRA which stands for Mini Industrial Robotic Arm Learning Package. Let me start by saying just a few words about my background. I am one of the faculty of Bicol University College of Industrial Technology, located at East Campus, Legazpi City, Philippines. Currently, I am an assistant professor and designated as the department chair of electronics technology. I'm also engaged in research and I handle research subjects in my department. The growth in robotics is opening many new job opportunities for people who can program, install, run, and maintain robots. Automation is helping to save and create jobs. Robotization and the development of AI, as well as as they have said a while ago, or artificial intelligence are global technological megatrends. And the field of robotics is rapidly developing and the demand for robots has accelerated considerably. Globalization has led most economies to further investment in human capital and intensify their economic policy towards skill formation. Skill formation has become an important motivation for a greater innovation in view of shorter product cycles. In preparing for a global career, students should try to acquire global competencies and multicultural skills. Education 4.0 is parallel with the birth of Industry 4.0. The latter demands more to former to sustain its revolution. Industry 4.0 poses a great challenge in the current education system to produce a different Filipino in modern world. Educational facilities, technological advancements, and most importantly, research were attributes and crucial determinants of a higher education institution to be ready and capable in becoming an education 4.0. Thus, Philippine higher education in relation to or in becoming education 4.0 must plan yesterday in preparation for the modern world and ensures that the demands of industry 4.0 are well taken not only in locally but globally. In the Philippine setting, mismatch between industry requirements and educational preparation of new entrants to the labor force also exists in the fields of computer and information science, engineering and the physical sciences continue to lag behind. A great divide still exists between the haves and have-nots, that are those academic institutions who have access to updated and state-of-the-art technology and to those who do not. This study was conducted for the purpose of designing and evaluating the MIRA or the Mini Industrial Robotic Arm Learning Package as an alternative learning tool and a robotic simulation technology solution in providing a set of experience to facilitate students' learning for STEM, which stands for Science, Technology, Engineering, Mathematics, Education. Working on a robot stimulates students to build their engineering intuition and emphasizes the meaningful problem-based learning through the integration and application of their knowledge, strategic problem solving, computational thinking, higher order thinking, logical and analytical reasoning. These are just few examples of the abilities developed by educational robotics. These are abilities that will be fundamental in a lot of professional areas. The objective of my study is to design, to construct, build this instructional device. And after that, uh, record the data and evaluate it from the experts. And based on the evaluation, that will be the result of my study. It will undergo evaluation from the selected experts in terms of the technical aspect and the pedagogical aspect of the robot through focus group discussion, documentary analysis, and interview. What is MIRA Learning Package? The Mini Industrial Robotic Arm, or MIRA Learning Package, is an instructional innovation in a new educational landscape, aims to introduce a new aid for teaching and facilitate learning for students to better appreciate the importance of robotics. This comprises of a training kit for simulations supported by modules and control systems in order to manipulate the robot kinematics and angular position, and accompanied by instruction manual that will provide a natural fit with good pedagogy that emphasizes meaningful problem-based learning, integration and application of knowledge, hands-on learning in cooperative groups, and demonstrable mastery of new learning, and will be made on the note of demonstrating lessons relative to robot arm position using an intelligent distribution board, base frame, and embedded system for control, how it functions, and to actually present the real sequence that makes every device, machines, and the like work. As I've said, the MIRA learning package is composed of a MIRA training kit. This is the brain center for robotic control and simulation, and it represents certain elements in the proper working and performance of this system. We have the Mini Industrial Robotic Arm. This one is an accessible, connected, 4-axis robot that can be powered by various microcontroller, and microprocessor prototyping boards. The small industrial-like robot is a force servo-driven robot arm. Can be manipulated through the controller or a computer. The user can manipulate or move the robot in 3-dimensional space and grasp or release objects with the end effector. Another interesting intelligent distribution is the MIRA platform. The MIRA platform serves as the base frame of the robot arm, while generating its movements and angular position from the panel board. It consists of terminals and pins where signals are sent to the wires of the robot in order to make actions. And the last part is the MIRA panel board. This intuitive interface board has an intelligent power distribution of electric signals as well as the digital used in surface wiring in order to manipulate the robot kinematics in angular position, an accessible panel board that controls the Mini Industrial Robotic Arm. This panel is equipped with input and output supply terminals, timer, analog instruments, a controller, sensor module, and other accessories to control and monitor MIRA. At present, this instructional device is applied for patent pending. It has a patent pending application in terms of the utility model and industrial design. Next is the methods of control. The Maya training kit will not operate without the different modules, sensors, and control systems to simulate the position and kinematics of the arm. These output devices serve as the controller from the distribution boards sending digital and analog signals to the arm. The following are the different accessories of the training kit that used for surface wiring connections, simulation, and hardware interfacing. So, as you can see, these are the methods of control, starting from the PC and mouse. The robotic arm can be also controlled by infrared, Bluetooth. Uh, the method of control is expandable. Uh, Currently, we are working on the IoT control, Internet of Things.
Huh?
Yes. This can be controlled through smart application from your mobile phones, voice control, gesture control, and sensors. Aside from that, this study was also made on the note of developing a teaching resource material that will serve as guide for teachers in providing a set of experience to facilitate the students' development of knowledge, skills, and attitude for the design, analysis, and application of and operation of robots using the robot arm. So the researcher was also developed 3 books. The first one talks about the lessons. We have the Myra Learning Package book, which also includes the information sheets, worksheets, and assessments. The other one is how to use and safety measures. We have the instruction manual. And the last one is the additional activities and experiments can be performed using the training kit. For the conclusions, the Mini Industrial Robotic Arm, or Myra, is an innovative educational platform aimed at providing diverse learning experiences to facilitate students' acquisition of knowledge, skills, and attitudes for the design, analysis, and operation of a robot arm. Second, the researcher introduced a new aid for teaching and facilitate learning for students to better appreciate the importance of robotics that will bridge the skill gap in preparing 21st century learners to be skilled workforce in the era of globalization. The mini industrial robotic arm was validated by the experts. So here are the results of the experts' validity, assessment on Nerd, a 4.65, an outstanding rating when they evaluated the 3 books. In terms of technical aspect, Mira garnered an general mean of 4.15, which is very satisfactory. There are only few observations and recommendations suggested on how I can improve the training kit. So, thank you for giving me the time to present my paper, and have a good day, everyone.
Thank you so much. Anyone, do you have any questions or feedback? How about Mr. Chair?
Let me pronounce the name first. Is it Kenji?
Kenji.
Kenji.
Kenji. So we call it G. Kenji, thank you very much for your presentation. Actually, your field is almost out of my domain, so I cannot give you any technical comment, but overall the presentation was nice and I can see that you have done a lot of work while going through it. So good luck for your research and future publications. Thank you very much from my
Thank you, sir.
side.
Well, thank you so much. Yeah, good work, Mr. Presenter from the Philippines. All right. Let me go ahead and call on the next presenter, Ms. Wayan Dipatari.